For our project, we did page 463, number 5. First, we took notes on pages 459 to 461. We discovered that, when given an equation, find the scatter plot, determine what type of graph it is, sine or cosine. In order to write a new equation to fit a cosine curve, given a sine curve, change the vertical shift, adjust the amplitude, adjust horizontal shift, and adjust the period. Adjustments. The vertical shift is the average of maximum and minimum values. The amplitude equals 1/2 difference between maximum and minimum values. The horizontal shift is a time at maximum value, and the period equals 2 pi over omega. Our question was called Annual Temperature Change. The table gives the average monthly temperature in Montgomery County, Maryland. Part A was to make a scatter plot of the data. To make a scatter plot of the data, we use Excel. In one column, the left column, we put our X values 1 through 12, which represent the months, January to December. On the column to the right of that, we put our Y values, which were the average temperature in degrees Fahrenheit. Then we clicked on Scatter Plot, and it automatically made a scatter plot for us. Part B was to find a cosine curve that models the data sine reg, the data from the scatter plot in Part A. Y equals A times sine, in parentheses, bx plus c plus d. A equals 23.44, which is the amplitude. B equals 0.481, which is the omega. C equals negative 1.845, which is the phase shift. And D equals 62.235, which is the vertical shift. We converted our equation to cosine from sine by subtracting pi over 2. Pi over 2 is a phase shift, so we subtracted it from 0.1845. We got y equals 23.44 cosine, in parentheses 0.481, and in parentheses x minus 7.101, close parentheses, plus 62.235. This is our cosine curve. Part C of our equation was to graph the function from Part B together with the scatter plot. We graphed our scatter plot along with the equation y equals 23.44 cosine times 0.481 times x minus 7.101 plus 62.235. The blue line represents our regression line. Lastly, Part D was to use a graphing calculator to find the sine curve that best fits the data. This is what we did in Part B. A equals 23.44, B equals 0.481, C equals negative 1.845, and D equals 62.235. Therefore, our sine curve equals 23.44 sine times 0.481x minus 1.845 plus 62.235. We came up with some important questions from the project and asked a few teachers. The first question was, can we use the same process in Part A to find the answer in Part D? Yes, using a graphing calculator, the equation for the sine curve can be used. The second question is, how do we add the graph of the line of best fit onto the graph of the new equation we found? We found the answer to this question by consulting with other students in Mr. T. A specific formula in Excel is needed. We did not have any failed attempts, but we had some challenges. We had a difficult time trying to figure out how to graph the line of best fit in the equation we found in the same graph. We also were not sure if the sine curve we found at the beginning of the problem is the same equation that Part D asked for. We hope you enjoyed this presentation by Sam, Corinne, and Riley.